Good evening.
Good evening, Anil.
Today we'll start Kubernetes. Kubernetes is a tool which comes at deployment stage. What is the other tool which comes at deployment stage?
Jenkins.
Jenkins is CI/CD tool. What is the another deployment tool?
Docker.
Docker is a deployment tool. Okay. Okay, Nitish.
So,
Hmm. All right. So Kubernetes is also called as K8s because in between K and S, there are 8 letters. UBERNETE, 8 letters. So K8S. K8S or Kubernetes, anything is same. Kubernetes is a container orchestration technology. Means generally in Docker, we have like single containers. We create single containers. But in Kubernetes, it is like a group of containers together. Okay. It is a container orchestration technology. So which that creates, deploy and manages clusters. So basically it's like bunch of Docker containers. Understood the main point, main idea?
yes.
It schedules, runs, and manages isolated containers which are running on virtual machines, physical servers, cloud machines, anything. So this Kubernetes has a set of containers. So these can be runs. These can be run on any of these machines. Like even you can set up Kubernetes on virtual machines. You can set this on physical servers, cloud servers, anywhere. Convert isolated containers running on different hardware into cluster. So isolated containers means like separate individual containers. So it converts that isolated containers into a cluster. Cluster is nothing but kind of a group together. So converting that isolated containers running on different machines into a single form, like it's like a cluster into a group. All three clouds support Kubernetes, like AWS cloud, Azure cloud, Google cloud supports Kubernetes. This Kubernetes is developed by Google company. Features of Kubernetes, like it has orchestration feature. Orchestration means clustering of any number of containers which are running on different hardwares, nothing but grouping containers together. Then it has auto scaling feature. Auto scaling means based upon the traffic, automatically containers will be increased. Then auto healing. Auto healing means, let's say this Kubernetes has 4 containers. If 2 containers are deleted due to some issues, then in place of that deleted containers, Kubernetes will create 2 more containers. Means it will replace unhealthy containers with new containers. That is called auto healing. New containers in place of crashed containers. Load balancing feature also there. It will distribute the traffic. Platform independent. It can be created on any platform. So it is independent platform. Platform independent. Fault tolerance, the same as auto healing. Rollback. Rollback feature is kind of undo feature. Like you can, if you made some mistake, you can go back. You can undo. Going back to the previous version. Any doubts in this slide?
No.
Kubernetes setup. You can set up Kubernetes with like mini kube setup, kind setup, kube ADM setup, kops setup, kube spray setup. Then in Kubernetes, for Kubernetes, we have services in different cloud platforms. I'm asking you one question. In AWS cloud, which service is used to launch virtual machines?
Is it Terraform?
In AWS, which service is used to launch instances, virtual machines?
EC2.
Okay. EC2 is the answer. Any confusions?
No.
Okay. Similarly, in AWS, which service is used to store data or to store any photos, files, documents? Which service is used for storing the data?
S3.
S3.
S3 bucket.
S3 service is used. Like now, in AWS, there is a service called to create Kubernetes. That service is EKS, Elastic Kubernetes Service. Just like EC2, Elastic Compute Cloud, how we use EC2 service for launching virtual machines. So in AWS, we have a service called EKS for launching Kubernetes cluster. In Azure, we have a service called AKS, Azure Kubernetes Service. In Google Cloud, Google Kubernetes Engine, GKE. Okay. Any questions here?
No.
Please ask if you people have any questions, anything. Don't sit silent. Okay, next. In Kubernetes, there is a new terminology called pod. What is pod? See, normally in Docker, we have created containers in EC2 instances directly, right? We created containers, right, directly in EC2 instances.
Yes.
But in Kubernetes, these containers are created inside pod. Container is created inside pod. So where the pod is created? Pod is created inside the node. Node is nothing but EC2 instance. So EC2, inside EC2, we have pod. Inside pod, we have container. Okay.
Okay.
Basically, pod is like a chocolate cover. If chocolate is container, chocolate cover is pod. Atomic unit of deployment in Kubernetes means it is the smallest unit of deployment in Kubernetes. Each pod can have one or more tightly coupled containers. Means in a chocolate cover, you can have one chocolate, two chocolate, three chocolate, like that. In a single pod, you can create one container, two container, like multiple containers. And this pod runs on node. Node is nothing but EC2 instance. So this node is controlled by whom? By master node. Master node is nothing but another EC2 instance, just like Ansible setup. We have master node, worker node in Ansible. You remember?
Yes, sir.
So here also, this master node controls these worker nodes. In those worker nodes only we have pod. In pod only we have containers. So in Kubernetes, we create manifest files. Manifest file. In Ansible, what do we create to create the infrastructure? Where do we write the code? Scripting.
Playbook.
Playbook. In Ansible, we use playbooks. Which language, which scripting language we used to create playbooks?
ML.
YAML. In Kubernetes, we call manifest. We create manifest. So this manifests are written in YAML scripting language. Okay. So once manifest is written, we have to apply this to cluster. Inside the cluster, I mean Kubernetes cluster, you have to apply. So who will take that manifest means master node will take. Master node is like class leader. Worker nodes are like the other students. Generally, class leader will control, right? The class leader will control remaining students. He will have some rights. Here also the master node can control. Master node will control the worker nodes. Okay. Now this is important. This is the architecture of Kubernetes. Okay. Just look into this architecture once. Read all the components, whatever you are seeing. Read anyone. What all components you are seeing here. Just give me a minute. I'm getting call. Okay, fine. So have you read what all components here we have?
Yes, sir.
In this architecture, so this particular one. Okay. So this particular one is Kubernetes master node. Okay. In Kubernetes master node, we have three components. One is Kube controller manager, Kube API server, Kube scheduler, then etcd or etcd component. So these four components are present where in Kubernetes master node. Then this is worker node. Worker node 1, worker node 2, worker node 3. Basically, node is nothing but EC2 instance. Okay. So in this master node, we have 1, 2, 3, 4 components. And in worker node, how many components? 2 components, kubelet and kube proxy. So here, how many worker nodes are there?
3 worker nodes.
We have total 3 worker nodes here. And how many master nodes we have?
1 master.
One master node. Okay. See, in this architecture, like what we do first we create one manifest file. Okay. So we have created a manifest file. Like my requirement is I want to create 3 pods, or I want to create 5 pods. So I have written the code in here. I have written the code in manifest file, and I'll apply this manifest file to Kubernetes master. How to apply? You have to execute a command. You have to execute a command to apply that. The command is kubectl kubectl create hyphen f file name. If the file name is main.yaml, then you have to give main.yaml. Simple command kubectl minus f kubectl create minus f file name. So once you execute that command, what happens in master node? First kube API server will receive that manifest file, and it will send that manifest file to etcd. It will send that to etcd component. So what is etcd? This etcd. This etcd is like, just give me a minute, wait. Why it is not? Okay. So this kube API server will receive manifest file. Once it receives the manifest file, it will send that manifest file to etcd component, nothing but etcd component. So what is this etcd component will do? It is like a database. It stores the cluster information. So this etcd component will store the Kubernetes cluster information, and then it will send back the manifest file to kube API server. Then what kube API server will do? It will send that manifest file to kube scheduler. What is the role of kube scheduler? Kube scheduler will read the manifest file, and it will see, okay, Arvind wants to create 5 pods. But right now in node 1, how many pods are there? Like 2 pods, here 2 pods, here 3 pods. Like the pods are designed are else like here 2 pods, here 4 pods, and here also 2 pods. Like that, the pods are created. So it will see 5 pods. If I keep in node 1, then it will be like huge burden. If I keep all the 5 pods in node 2 also, huge burden. Like equal distribution is not the right. So it will decide, okay, we already have here 2 pods, here 4 pods, here 2 pods. No, so let's distribute in this manner. Here 4 means let's give only 1 pod. Here let's give 2. Here let's give 2. So that equally the load will be distributed. Like that it will decide, and it will tell to Kube API server. Then finally, who is going to create the pods? Kubelet will create. So Kubelet will go to Kube API server. It will get the information. Okay, I have to create 2 pods. So it will create 2 pods here. That Kubelet here, it will go and ask, is there anything like how many pods I need? You only create 1 pod, it told. So this Kubelet will create only 1 pod. This Kubelet will create 2 pods. Once the pods are created, the application, whatever we kept inside the pod, like the containers will be created and the application will be running. After some time or after many days, like whenever, if any pod is deleted, actually here we should have 4 pods, but right now we have only 3 pods. So immediately Kube controller manager will get to know. The duty of this component is it always monitor the status, like actual state and desired state both are equal or not. Means pods should be 4, but right now how many pods are there? It will check. If it is not matching, if the pods are not matching, then it will inform to cube cube scheduler, then it will decide, then again finally kubelet will create the pod. So this is the architecture, Kubernetes architecture. Once again, I'll repeat everything from starting onwards. Whoever did not listen, focus once again. So in Kubernetes architecture, mainly we have two things: master node, Kubernetes master node, and Kubernetes worker nodes. Master node is like main thing which control all the worker nodes. In master node, we have 4 components called Kube Controller Manager, Kube API Server, Kube Scheduler, etc. In worker nodes, we have kubelet component and kube proxy component. Once we create the manifest file, we apply that manifest file by executing a command. So once you execute that command, who will take that manifest? Kube API server will receive that manifest file. It will thoroughly read the manifest and it will send that manifest file to etcd. So this etcd component will read the manifest file. It will store the information completely here. So the duty of this component is it has to store all the information about this Kubernetes cluster. Then it will send back the manifest file to Kube API server. Now, what is the role of Kube scheduler? It will decide who should, like the pod should be created on which nodes. How many pods should be created on this node, on this node? It will decide. Accordingly, the kubelet will create. And this kube proxy component is responsible for the communications between the external and internal. Means from inside the Kubernetes cluster, the application is accessible by the outside people. So that traffic is coming inside and going outside. That is because of kube proxy. Kube controller manager, which always checks actual state and desired state of the components. If both are not equal, then it will try to replace. So this is about Kubernetes architecture. Any questions?
No, Arvind.
All right. And one more thing, in your interviews, you better don't say I know Kubernetes everything very well, because Kubernetes is not something which you can learn in 1 class or 2 class. Kubernetes is like vast subject, very, it's like a ocean. Okay, so if you tell I know Kubernetes, then you will be in trouble, like uh, because they will expect very much. What you have to say then in that case? You should not say I don't know. You should not say I know. You have to say, like, in our project, Kubernetes is not used, but if you give me, but I'm ready to learn Kubernetes and I'm ready to work in Kubernetes project also. Just I need like few days of time, 1 week, 2 weeks. Then I can learn Kubernetes and I can start working on this. Since I did not get any opportunity in my current project to work on Kubernetes, so I don't have real-time experience. Like in that way, smoothly you have to answer. because my project requirement will be different. Though I am a cloud engineer, AWS cloud engineer, in your company your project requirement is different, the other company's requirement is different. So whatever the tool I am using, your company might not use, and the other person's project also might not use. So it is not mandatory for everyone to learn every service, but you should have basic idea, basic understanding. So that even if you don't have any knowledge, once you enter into the organization, people will have KT, they will learn and they can work. But going with zero knowledge is like blank, right? Like that is not acceptable, no. At least you should have basic understanding. So same thing you have to tell them. Understood?
Okay, Arun.
I mean, just one doubt. Suppose they will ask like what containerization tool you have used. So should we tell only Docker?
Yes, that is better, right? Because which one you are comfortable? Docker only, no, obviously, or not. If you're
Oh.
not comfortable with Docker also, then it is an issue for you only.
Hmm. So currently we have only two, Docker and Kubernetes containerization
Deployment tools.
deployment tool. Yeah.
Mm. See, no, next one is Kubernetes objects. So what is Kubernetes object? There are many objects in Kubernetes. Most of the Kubernetes objects consist of 4 top level fields. What are they? So let's try to understand here clearly. So what I said, we create manifest files. So like main.yaml, something. So I want to create 2 pod. So understanding this. So, so this is node. Node means what? EC2. Inside node, we can create pods. Pod 1, pod 2, like that. And inside pod, you can create container. Container 1, container 2, container 3, container 4, like that. So which one is the higher level? Node. Inside that pod, inside that container. So these containers are created using Docker image. All these are Docker containers only. Okay.
Okay.
So now how to create a manifest file? You have mainly these fields. API version first. First field is API version. So what should be the value here? What I have to give for API version? What is the next field? Kind. And what is the next field? Metadata. And what is the next field? Spec. Like this, we have different fields. So for example, I want to create a pod. So pod is an object. See, Kubernetes objects. First, we are discussing about pod. I want to create a pod. So here you have to mention in this field kind. What kind of object you want to create? We have different objects. Pod is an object. Service is an object. Deployment is an object. Like namespace is an object. Like many objects are there. I want to create pod. So you write here pod. Understood this? What kind of object you want to create? Mention that object name.
Yes.
If you want to create pod, then the API version for pod is like different. Like it is like V1. We have different kinds of API versions for different objects. If you want to create pod, then the API version is something like V1. Here you can see the chart. If it is pod, then V1. If it is replication controller, capital V1. Service means small V1. Replicas, it means apps/V1, like that. So accordingly, give here API version. So here I want to create pod, so we giving V1. Then metadata. Metadata is metadata, it consists of two fields. What is that? First one is name. Here you have to define the name. So for that pod, what name you are suggesting? See, I am a human being. There are different objects in the world. Human being is an object. Animal is an object. But human beings, we have different names. My name is Arvind. Your name is different name. Like that. Here, kind is pod, like human being. So what name you want to give for this human being? You mention here name. Name, uh, like like front end pod, FE pod or Java pod something. Then label. If you want to give any label, you can give the label. Label. So this is, let's give Java pod. Like this is front end pod. Label means, see, in a class there are 50 students, 25 boys, 25 girls. I said, boys, all of you stand up. Then how many people will stand?
25.
25.
Because the label which we have given for this 25 is boys. Here the label is girls. If I say, Kiran, please stand up, means only Kiran will stand up. If I say the label for this 25 people, common thing, common name, boys, right?
Yes, sir.
So similarly, here also we can give labels. For example, we have 10 pods. 5 Java pods are there, 5 some .NET pods are there. I want to upgrade Java version, but that Java version is present in Java pods only, not in .NET pods, right? So for these 5 Java pods, I can give one name, like front end pods. For these back end pods, I can give the label. Understood now? Labeling means.
Yes, sir.
Okay, next, spec. Spec means specification. In spec field, you have to give all the details. Like my name is Arvind, means that what is my age, what is my mobile number, what is like, my home address, like all comes under specification here. So we define all configuration here, configurations under spec. So this is how we define a manifest file. These are the different types of fields, 4 top level fields. Now coming to here, first object, what is pod? You already know pod is like a wrapper for containers, means it is an outer layer. If this is a chocolate, so this is chocolate cover. So this is pod. So this is container. Okay. Kubernetes identifies only pod, not container. That means in India, we have one prime minister and multiple chief ministers. In each and every state, we have chief minister. In Telangana, one chief minister, Andhra Pradesh, one chief minister, Kerala, one chief. And again in Telangana, you have like lots of MLAs. Here also you have lots of MLAs here also. If prime minister want to arrange one meeting to discuss some issues, whether he will arrange meeting with chief ministers or MLAs.
Chief Minister.
Are you sure?
Yes, sir. Because he doesn't know MLAs.
He will interact with higher level only, right?
Yes, sir.
So similarly here in Kubernetes, Kubernetes master node will interact with pod, not with container. Okay.
Yes, sir.
So Kubernetes identifies only pods, not containers, and each pod can have one or more containers. Here in this pod one, how many containers are there?
2 containers.
In this pod, how many containers are there?
One.
One container. And this pod having an IP address called 10.0.30.50, and it is also having like 10.0.30.60. Both same or different?
Different.
Different. And in this pod we have a one container. For this container, which port we open?
Port 8080.
For this container,
Port 3000.
port. Let's say we hosted Facebook application here, we hosted YouTube application here, and see, I want to access Facebook application. So my request should go to where? This container, right? So how it will go? Through this port only. So how should I access this Facebook then? 10.0.30.50 colon 8080. So this is how I should give. If I want to access something from this container, then 10.0.30.50, same IP address, but different port number. Understood?
Yes, sir. Understood.
So we create manifest file and we apply that manifest file to Kubernetes master node. Who will receive this manifest file? API server. Once API server receives manifest file, it will create the infrastructure like this. Now, how to create a pod, like sample code, how the code will be. So let's say the file name they have given here is nginx-pod.yaml, YAML scripting. Okay. Next, first, what is the first field? API version, kind, metadata. So kind, what kind of object you want to create? I want to create pod. So for a pod, what is the version? API version v1. Then metadata, name of the pod, nginx pod, means human being name is Arvind. Like labels, like if you want to give any labels, you can define the labels. Like they have given app nginx side dev some labels. Then spec means specification. In specification, I'm mentioning I want to create containers. To create a container, do you like we need to specify container name also, right? So the container name is nginx container. And to create a container, we need a Docker image. So what is the image name?
Nginx.
Nginx image. So it will create a container called nginx container, where it will create
Nginx pod.
in nginx pod. This container is created using which image?
Nginx image.
Nginx image. Is it clear?
Yes, sir.
So once this file is created, then you have to execute this command kubectl create -f pod file name. Then it will create the pod. Then how to check if the pod is created or not? Kubectl get pods. This command we have to execute to see the list of pods. Any confusion? Am I confusing anything?
No, Arvind.
Why only one person is responding? What happened to remaining? మౌనవ్రతం ఉందా?
It's clear.
See, I'll tell you one website. So codecloud.com. So this website has many practicals you can do here. If you want to practice Kubernetes, you can practice here. If you want to practice Kubernetes, you can practice Kubernetes. Docker means you can practice Docker, everything. Now let's go with Kubernetes with beginner. Beginner. It will ask questions. We need to answer it. It is like an exam. Okay.
Yes, sir.
So first, what you see, this is like here practically they will give us one shell, one command prompt shell where it has Kubernetes installed readily, and it is asking us first question: how many nodes are part of the cluster? Nodes means what?
EC2 instance.
Nodes are nothing but EC2 instances. Cluster means it is like Kubernetes cluster that setup. So each Kubernetes cluster can have how many nodes? 1, 3, 5, 6, 4. It is asking. See, there is a algorithm also. You have to give in like odd number, either 3, 5, like some sequence is there. That is a big algorithm only. So that this is not that much important. So randomly you tell any guess how many nodes are part of the cluster? Minimum.
Minimum 4. 3.
Let's okay, we'll go with 3 then. That is saying not. So if you don't know the answer, sorry, I got confused.
One.
No, not that. See, I have to explain something. I'm explaining other thing about this. See, here they will give questions. So how to answer these questions means by executing the commands here. You need to execute the commands and you have to get the output. So what is the question? How many nodes are part of the cluster? Means how to verify the number of nodes. So Kubernetes command starts with kubectl. After many days I'm using this, so I forgot. So kubectl get nodes. So let's try this command. Kubectl get nodes. How many we have? Like name control plane master. These two have. What exactly it is asking count. So let's use chat GPT. Just simply ask kubectl command. This code cloud platform is very helpful. Okay, kubectl command to see list of nodes. Kubectl get nodes. So the same command, right, I have given.
Yes, sir.
Kubectl get nodes. See how many it is showing control plane node. So as of now, how many nodes are there? Only one, right? So the answer is one. Correct. Understood?
Yes, sir.
Now, next one. What is the version of Kubernetes running on the nodes? So how to check the version of Kubernetes? Kubectl hyphen version. I think so. Oh, what is version of Kubernetes running on the nodes? Kubectl. Let's ask here only. Kubectl. Kubernetes version command. Okay. Kubectl just version, not hyphen. So this one v1.29.0. Okay, v1. So this one only read the answer.
Yes, sir.
Yes, sir.
Now next question. What is the flavor and version of operating system on which the Kubernetes nodes are running? How to check? This is Linux command. Forgot how checking operating system details. So you open this platform, open chat GPT like that. You can learn many things. You can explore many things. Will you do that?
Yes.
Yes.
See, because Kubernetes is not something to explain just definitions kind of thing. This is more about practical. It's not like A for apple, B for bad. Like you should not by heart like that. If you do the things practically, then only you will understand lot of things. Okay, this is already done, right? How many nodes are part of the cluster? This one.
The battery is
No, this is not beginner. With this one. Same questions. Kubernetes. Maybe not beginner instead of beginner. Like we have to go to some Maybe after finishing complete beginners only, we'll get next one, intermediate. Beginner, we'll go with this one. We'll try. Git command starts with what?
Git.
It,
Yes. Docker command starts with Docker. Ansible starts with Ansible. Terraform command starts with Terraform. Kubernetes command starts with kubectl. Kubectl nothing but kube control tool. You see, what they're asking, how many pods exist on the system? Means they're asking how many how many pods, pods are present. How will you check? Kubectl. Simple commands, get pods. Do we have any pods here?
No.
So in the current default namespace, then what is the answer?
0.
So in this way, you can practice the commands or not.
Yes, sir.
So if you know at least these basics, then in the interview, you can tell like you have some at least like you practiced this without having practical knowledge, just going to the documentation, you cannot remember. Okay. Create a new pod using the Nginx image. It is asking. So directly it is asking to create a new pod. You know, right? Already just sometime back we have saw the so using Nginx image we created like not we created. I have shown you the pod, the file. If you give the same code, copy and paste here, then it will create the image. Okay, it will create the pod. How many pods are created now? Execute same command. How many pods are created now? How many pods are there now?
3 pods.
This is the first pod. In this pod, how many containers are there?
Contain.
Huh? How many containers are there in the first pod?
One.
Only one container is there, and that one container is ready. In second pod also only one container is there, that one is running. Third also one container, one by one running. Created 57 seconds ago. So what is the answer here?
3.
Three pods. Which image is specified for the pods whose names begin with new pods hyphen prefix? You must look at one of the new pods in detail to figure this out. So what is the question?
Asking for which image is installed in containers with new pods. Sorry, pods with new pods.
So let's describe the pod. Kubectl, describe pod. Which pod? Give pod name. Hit enter. So we have described the pod here, and you can see pod name. Here I have executed the command kubectl describe pod name. What is the name of the pod? This is the name. So this pod is created in default namespace, and image. Just come for image here.
Zip.
Containers. See this containers. What is the container name?
Busy box.
Busy box. This busy box container is created with which image?
Busy box.
Easy box.
Again, scroll down. Do we have any other containers? Means no. That's all. Only one container, right? In this pod, one by one. So what is the answer here?
Busy box image.
Understood?
Yes, sir.
So in this way, you have to practice. Kubernetes installation is not that simple and easy. It is very like huge kind of infrastructure. Like it might deduct money also from your AWS account because it needs 100 GB storage, like huge RAM. So no need to practice Kubernetes installation setup. Directly you can use this lab for practicing the commands. Okay. And tomorrow I'll take the session Tomorrow I'll explain you the final project, and let's have the resume preparation part. So by tomorrow I'm going to finish DevOps. Okay, guys?
Okay.
Tomorrow mostly, which time is better? Evening?
Interview questions as well. Like,
Yes. Like interview questions means there is nothing like same questions which in interviews they'll ask scenario based only, not
mm,
direct questions. Yeah. So I will take the session tomorrow. So you suggest morning time, evening time. Tomorrow is Saturday only.
Any time is fine.
Okay, if any time is fine, then tomorrow morning I'll take around 11 a.m. Is that okay? 11 a.m. Let's connect from morning 11 a.m. to till 12:30 like that.
Tomorrow for there is office.
You have office,
Yes, I will be free after 7.
so you take leave for 1.5 hour tomorrow. Okay.
I will
Any questions from anyone?
no.
No.
Okay then. Thank you.